So, Mozart Symphony Number 41. If you're wondering, I was asked specifically about parametrics. The major thrust of parametrics is about x being related to a parameter, y being related to a parameter, and then, one of the skills and the major skill that we're going to focus on today is then finding how to relate x and y directly. Sorry, x equals 3 minus p and y equals 2p plus 1. In this case, one of the easiest ways to do it is to rewrite the equations where p is the subject of the formula and then equating p p expressions gives 3 minus x equals y minus 1 on 2, which is to say basically y equals, 6 minus 2x and then plus 1, so 7 minus 2x is the direct function relation, the direct relation between x and y. That's an easy one. Two lines, parametrically, 2 lines will end up being another line. When I think about that, a line of a line is a line, basically, yes. In B, it's a little bit trickier. You've got x equals 1 plus 2 tan theta and y equals 3 sec theta minus 4. That's a pair of parametric equations where the parameter is theta, as in x relies on theta and y relies on theta, but you're interested here in how you could directly relate x and y without the parameter. That's otherwise known as finding the Cartesian equation. The Cartesian equation, because you're looking from an xy plane, basically. You're trying to relate x to y rather than to have a sort of theta x and then separately a theta y, and then those two graphs are somehow related to each other. How they are is a mystery until you actually relate x and y. So, especially in these graphs, that will be quite complicated. You're looking at, there's a tan theta and then there's a sec theta, and you're drawing on your understanding of trigonometric identities, the famous Pythagorean one. When you divide throughout by cos squared theta, you get sine squared theta and cos squared theta is tan squared theta plus 1 equals sec squared theta. I'm hoping at this stage of your revision that is a well-known idea. And so really, you're looking to rephrase these in terms of those. So if we just work on x to begin with, obviously you would do x minus 1 all over 2, x minus 1 all over 2, and then square it will give you tan squared theta. And then y minus 4 over 3 squared will be sec squared theta. And then, you may as well just quote it. And then from this result, you get x minus 1 over 2 all squared plus 1 equals y minus 4 over 3 all squared. Now, you don't have any reason why you would know this, but this turns out to be a hyperbola. This is a hyperbola that's really basically outside the nature of the course. The base hyperbola that you sort of learn, it's not called a rectangular hyperbola, although it is a rectangular hyperbola. Let's do this. That one, this is for interest's sake. That one has diagonal asymptotes that are inclined at 45 degrees. It's not very well drawn. More like that. If you imagine these as the sort of x and y coordinate planes, you'd get this is xy equals 1 or y equals 1 over x. Sorry, I've done it the wrong way around. Y squared minus x squared equals 1. No, No, I haven't done the wrong way around. I did it the right way around originally. X squared minus y squared equals, when y equals 0, x equals plus 1. That makes sense here. That's the sort of base parabola there, where that's x and y. That's your x coordinate and your y coordinate. Your x axis and your y-axis. This one here is obviously a translation and a stretch. This is various transformations going on. In this one happens to have a perpendicular pair of asymptotes, but this one certainly does not. Anyway, that's just an aside. You're not being asked to understand hyperbolas. You're not being asked to graph this function. You're only being asked to find the Cartesian equation of the curve. Now, that is the Cartesian equation of the curve. It's no function. X is not a function of y is not a function of x there at all. It's a complicated relation. But you could pretty much stop there. There's no real reason why you need to simplify it further, but you might decide y minus 4 all squared. So 4, y minus 7 minus 9, x minus 1 all squared equals 36. Times 1 times 4 that's right. You might try that. I mean, it's not really helpful. I wouldn't really expand it further. There's no real need. I don't know the form of the answer to that question in the textbook, but I don't really much mind either. I might do C and D here as well, just for completeness sake. Okay, so question C. You've got x equals p plus 1 on p, and y equals p squared plus 1 on p squared. Now, I'm hoping that you see there that there's definitely something going on with x squared. You're obviously trying to square those terms. It's not as straightforward as that. When you square that, you get p squared plus 2 times p times 1 on p. P squared plus 2 times p times 1 on p plus 1 on p all squared, which is p squared plus 2 plus 1 on p squared, which I'm hoping you're seeing is y plus 2. So you've got y equals x squared minus 2 is the nature. It's quite clearly a parabola. It's in fact a function. Y is a function of x there. That worked out quite well. D, bit trickier. X equals cos theta plus sine theta. Y equals cos theta minus sine theta. And yeah, you can try and combine those in various ways, add them together, and you get x plus y is 2 cos theta, and maybe x minus y is 2 sine theta, and then somehow square one and square the other. You could probably go down that route, but I'm probably a bit more used to being able to see that x squared equals x squared here equals cos squared theta plus 2 cos theta sine theta plus sine squared theta, and y squared equals cos squared theta minus 2 cos theta sine theta plus sine squared theta. And in both cases, maybe this is not the cleverest layout for this question. It might be cleverer to sort of do it like this. That's not certainly not therefore. If x is that, then x is that, x squared is that, and y squared is that. We're sort of running out of space there a bit. Okay, if x squared is that, and therefore x squared is 1 plus 2 cos theta sine theta, because sine squared theta plus cos squared theta is 1, and y is 1 minus 2 cos theta sine theta, and you fairly quickly, y squared, you fairly quickly get to an x squared plus y squared situation, and I think you can see that it's 2. It's a circle center, the origin radius 2. So those are some of the tricks, basically looking at them, squaring various things, adding them, using trig identities, etc.